Hello and welcome to Chem Help ASAP. In this video, we're going to use oral CP time data points to calculate PK parameters, namely oral bioavailability. Let's perform some sample calculations on oral CP time data. Now, typically, if you're looking at oral data, there's been a previous test for IV data on the same compound. So up here, I'm assuming that that's the case and that we have some IV data that has come before this oral data. What would you get from the IV data? You would know the elimination rate constant. You'd know the half-life. You'd have the area under curve for whatever your dose was for your IV dose. You'd also have clearance and volume of distribution. So now then, once you have the IV data, you follow along, and if it's going to be hopefully an oral drug, you would gather some oral data. So here we have our time points, we have time in hours, and we have plasma concentration in nanograms per milliliter. Our dose is different, our dose is higher. It's pretty standard for the dose to be higher, for the oral study to be higher than for the IV study. Maybe twice as high, maybe 3, maybe even 5 times as high, depending on the properties of the compound. So our first job is to insert a chart, and let's just visualize our data. Let's take this, let's get our range. There's our data set. Okay, I don't want a column chart, I want a scatter plot. So here we go. And here's our chart. We see the typical rise and fall of an oral curve. Let's go into an application where we can look at this graph a little bit more closely. Okay, here are our oral data points. This is CP and time, and CP is in hours. And I'm sorry, CP is not in hours, time is in hours, and CP is in nanograms per milliliter. Okay, good. So you can see these data points, they sort of form this curve. This is a standard oral curve. We get a nice rise, and then the concentration slowly tapers off. I'm missing those data points, but you get the idea. So from these data, we're going to have to generate, we want to determine the bioavailability, F. And to determine bioavailability, we need to determine the area under curve for this oral dose. The technique for determining oral AUC is the same as IV AUC. We're going to break this into regions. Let's say we take this region. Between those points, this has a delta T range. So that's sort of one dimension of our trapezoid. And then we'll take the average of these two data points, and that determines the height of our box. And so we can determine this area. We can do the same over here. We'll determine this area as a set of trapezoids. And then we will add those up and determine our area under curve. Just as we did with the IV data, we're going to have to deal with this last area that goes beyond our last data point, or beyond CP last. We have to estimate this area. But that's okay, we know how to do that, so let's go ahead and do it on the spreadsheet. Well, back in the spreadsheet, this graph is beautiful, but it's getting in our way, so let's delete that so we can have some more space. So what will we have? We are going to have over here, and let me pull these down, just get them away from everything else. Okay, we want a time interval. We want to know the average CP value, and from that we're going to do our calculation. So the time interval, we'll start with this cell. The time interval from the previous cell is simply that cell less the previous cell. So the first trapezoid is going to be a 1 hour wide trapezoid, and then we want to get the average. Well, it's not, we can do it. There are many ways to get an average. We can take this value plus the previous value divided by 2. That's the average value over the course of that hour. And now we can just copy this range down here. So we have 1 hour intervals. Some of these are 2 hour intervals, and then a couple of those are 8. And we can calculate our average values there. Good for the average value for the plasma concentration. And to determine the area, we just multiply these two values. So, and it doesn't autofill. Very polite. Thank you so much. And so this is what we get. Now, I did mention that last area. Just as we have seen for an IV data, we can calculate that last area based on our CP last, which is 41. So this is going to equal CP last divided by our KEL value. And we know our KEL value. We didn't determine it with the oral data, but we would have it in hand previously from the IV data. So I'm just going to click on this cell up here. It's 0.08 inverse hours. Enter. And this is our AUC last. Now, if we total these up, the sum of all these different regions of the curve is that, and that's our AUC total. Now, this puts us in a position to discuss our oral bioavailability. Let's go to the other application. Okay, at this stage, we have everything we need to determine oral bioavailability. So the symbol for bioavailability is F. And to determine this, we're going to compare the oral exposure divided by the IV exposure. And so we assume that the IV exposure defines 100% exposure because you're completely certain that the drug got into the central compartment, into the plasma, because it was injected into a vein. For oral exposure, you're not so sure how much of it actually made into the body. So how do we determine exposure? One way to determine exposure is through area under the curve. So we're going to compare our exposures from the different routes of administration. So for F, we are going to look at the IV exposure, the area under the curve from the IV, and we're going to normalize that based on the dose size, the IV dose size. And then we're going to compare that on the top. We're going to have the area under curve from the oral dose, the oral CP time curve, which we just calculated, and we're going to divide that by the size of the oral dose. So if you use a different oral dose size, you have to put a correction factor in for that. Otherwise, you're not comparing two of the same dose. And this is going to give you some value. It's going to be between 0 and 1. So we're going to get some kind of fractional value. If you want your F in percent, you can multiply by 100, and that'll give you a percentage as your bioavailability. All right, let's wrap up this calculation from our spreadsheet. So here we're trying to calculate F, and F is going to be, on the top, we're going to want to have the area under curve from our oral dose divided by, I'm going to break up this calculation a little bit, divided by the dose size. Okay, the dose size we know is 40, so we'll put that over 40. That's going to be our numerator in our calculation for F. And we're going to put that over our area under curve for our IV dose divided by the IV dose. And, I did put it here. Okay, area under curve, that's for a 20 milligram dose. So we want to divide that by 20. And so our F value is simply going to be that value divided by the IV value. And we get about 0.69, 0.70 is, I think mathematically when I did this, I set this up as 0.70, but you can see we have some rounding errors we carry through. So that's our F value. That's the oral bioavailability for this compound. F is 0.069, or 69% is the oral bioavailability. So that's how we use the oral data in conjunction with the IV data to determine the oral bioavailability of a drug. I hope you now have a better understanding of how to calculate oral bioavailability, in part from oral CP time data points. Thank you for watching. Please leave any questions or comments at the end of the video. Take care.